Hi, we are Team 3 and this is
Alondra, Regina,
and I'm Anna, and we're going to do problem 6.
That's what people say. I go on to
In this project, we will use what we have learned in this partial of linear models. Linear models describe a continuous response variable as a function of one or more predictor variables. They can help you understand and predict the behavior of complex systems or analyze experimental, financial, and biological data. Some of you might be thinking, who even invented a linear model? To solve that, we must remember and see what is a linear model. Like we said, a linear model is a linear equation for a straight line, which shows increase or decrease of anything. And who invented this? The inventor of such a useful thing was Sir William Rowan Hamilton. He died September 1865. He was an Irish astronomer and mathematician who made important contributions to classical mechanics, optics, and algebra. His biggest advance to math was the linear models. He was only 18 when he found this out. The astronomer bishop Dr. John Brinkley remarked this Hamilton as an 18-year-old, saying, "This young man, I do not say will be, but is the first mathematician of his age."
but I keep cruising. Can't stop, won't stop grooving. It's like I got this music.
Okay, now we're going with the flowchart. First, to start, we have to analyze and read the problem. Then we have to use the linear models to solve the issue. Then you have to ask the question, did it solve the problem? If the answer is no, you have to start from the beginning. If the answer is yes, you have to start making your graph. Then you have to review your answer, see if everything is correct, and then you have your problem.
Shake it off, I 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 shake it off.
A small appliance manufacturer finds if he produces X toaster ovens in a month, his production cost is given by the equation y is equal to 6x plus 3,000, where y is measured in dollars.
Sick beats. My ex-man brought his new girlfriend. She's like, oh my god, but I'm just.
What do the slope and the y-intercept of the graph represent? The y-intercept represents the fixed cost. The cost of production is equal to 0. Slope represents the cost per unit of production. There are $6 for each toaster oven. Now, to find the production cost after he produces 150 toaster ovens equals negative y equals to 6 times 150 plus 3,000 equals 900 times 3,000 equals $3,900. As more toasters ovens are produced, will the production cost increase or decrease? It will increase because the fixed cost is 3,000 and the cost per unit is $6. Then if I produce more, my cost will increase by 6 for each oven I make.
I shake it off, shake it off, I shake it off.
We use GeoGebra to graph our function. So we just put the equation and it graphs it automatically. The y-intercept is 3,000, which means the fixed cost. The cost of production equal to 0. And the slope in this represents the cost per unit of production, $6 for each toaster, which is how it gets up.
So, this is our y and this is our x-axis.
I say I'm too late. Got nothing in my brain.
This problem, we can observe a real-world application of linear functions. In this case, the linear function represents the cost of production of small manufacturing. The cost function is made of two different parts. The y-intercept that represents the fixed cost, the cost of the production equal to 0 units, in this case was $3,000 a month. And the cost per unit of production, in this case was $6 for each toaster oven produced at a month. So the function of the cost represented by y equals 6x plus 3,000, where it's measured in dollars. These kind of functions can be used to many different situations. We can make a function of income and a function of profit also. The cost function can be used from any business case.
Shake, 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 shake.